At the bottom of the ocean, there is water that is 750 degrees Fahrenheit, hot enough to melt lead, hot enough to incinerate human flesh in milliseconds, and it is not boiling. This isn't science fiction. This is real. Right now, beneath miles of ocean water, there are towers of superheated rock spewing fluid hotter than a volcanic lava field, and surrounding those towers, impossibly, is life. Lush, thriving, bizarre life that has never seen the sun. Life that breaks every rule about what living things are supposed to need. Stay until the end, because the final reason this place exists will change the way you think about every ocean, every planet, and every living thing in the universe. This is one of the most important places ever discovered on Earth, and most people have never heard of it. It's February 1977. A team of marine geologists is sitting on a research vessel 400 miles off the Galapagos Islands. They've lowered cameras 8,000 feet into the ocean. What comes back on those cameras stops everyone in the room cold. The seafloor is glowing. The geologist leading the expedition is Robert Ballard, who will later become famous for finding the Titanic. But this discovery, most people argue, is bigger. Ballard and his team are seeing warm water drifting out of cracks in the ocean floor along what's called the Galapagos Rift, a giant fracture where two tectonic plates are slowly pulling apart. No one predicted this. There were no biologists on board, because no one thought anything could survive down there. No sunlight, no warmth, crushing pressure, complete darkness. Life, as far as science knew, needed the sun. Then the cameras showed the truth. Clustered around the vents were entire ecosystems, tube worms 2 meters tall, ghostly white crabs, clams the size of dinner plates, alive, thriving, in total darkness. Under crushing pressure, in water that by every known rule should have been uninhabitable. But before the team could understand the life, they had to understand the heat. How could water down there be 750 degrees and not boil? And what kind of force could create something like that at the bottom of the sea? To understand why this water doesn't boil, think about what happens when you cook pasta in the mountains. At high altitude, the air pressure is lower. Water boils at a lower temperature, around 95 degrees Celsius instead of 100 degrees Celsius. The pasta takes longer to cook. Less pressure, lower boiling point. Every chef who has cooked at altitude knows this trick. Now flip it. What happens if pressure goes the other direction? Not lower, but thousands of times higher. At 8,000 feet below the ocean surface, the pressure is not just a little higher than at sea level. It is several hundred times higher. The entire weight of the ocean is pressing down from above. Under that kind of pressure, water's boiling point skyrockets. The molecules are squeezed so tightly together that they cannot separate into steam. They have no room to escape. So even at 750 degrees Fahrenheit, over 7 times hotter than boiling water on the surface, the liquid stays liquid. It can't boil. Physics won't allow it. And that's how water this hot can pour out of a crack in the earth without instantly turning into a cloud of steam. This is the same reason geysers like Old Faithful explode upward on land. The water underground reaches boiling and then some. The moment it hits lower pressure near the surface, it flashes instantly into steam. On the deep sea floor, that flash never comes. The ocean holds it down. But at the very hottest vents, the ones nicknamed black smokers, something even stranger happens. The water doesn't just stay liquid. It stops being liquid at all. And it stops being gas, too. It becomes something that has no name in everyday language. Scientists call it a supercritical fluid. It's a state of matter that sits between liquid and gas, possessing properties of both simultaneously. It flows like a liquid, but expands like a gas. It has no surface tension. It can dissolve materials that neither water nor steam could touch alone. To reach this state, water must exceed what physicists call its critical point, around 407 degrees Celsius for seawater, and be under extreme pressure. The deepest known hydrothermal vent, located in the Cayman Trough at nearly 5,000 meters below sea level, has been confirmed to produce sustained supercritical fluid venting. That means there is a place on Earth right now where water exists in a state that has no equivalent anywhere on the surface of this planet. And as this supercritical fluid rises through the rock, it is dissolving metals, iron, copper, zinc, lead, cobalt, pulling them up from deep inside the Earth. When it blasts out of the vent and hits the freezing cold ocean water above, Those metals precipitate out in an instant, forming towering black and white chimneys of mineral deposits. Some of them are over 30 feet tall. They are essentially factories, building themselves in real time on the ocean floor. Let's think of a hydrothermal vent, not as a place, but as a chemical factory. The super hot fluid shooting out of them doesn't just carry heat. It's loaded with dissolved metals and simple ingredients like carbon dioxide and hydrogen. As this fluid blasts out, it crashes into the freezing cold seawater, and right where they meet, to the surfaces of the vent chimney itself, something incredible happens. You get these wild swings in temperature and chemistry. It's like millions of tiny natural test tubes lining the rock. Inside these microscopic chambers, simple molecules are forced together. They react. They form more complex stuff, the basic building blocks of life, like amino acids. This is a huge deal. It's why many scientists now believe life didn't start in some sun-warmed tidal pool. It started right here, in the dark, in one of these natural chemical labs. Here's the kicker. These factories don't run forever. A single vent might only blast superheated water for a decade or two before the volcanic plumbing down below shifts or clogs. When the hot water stops, the party's over. The giant tube worms die. The whole ecosystem collapses. So how does life survive? How does it pop up again miles away when a new vent forms? The creatures have a wild trick. Babies, the larvae, don't just drift aimlessly. They can hit the pause button on life. They enter a kind of suspended animation, floating through the near-freezing, pitch-black abyss for years. They're waiting. It's waiting for a single chemical signal in the water that says, "Hey, new vent, this way." Then, they wake up and move in. Now, here's where we come in, and it's not a pretty picture. Those mineral chimneys these vents build are packed with gold, copper, and silver, seriously rich, and big mining companies are now building robots to go down there and scoop it all up. Now back to the life, because this is the part that shook science to its core. Every food chain on Earth, every single one, was believed to start with the sun. Plants absorb sunlight and convert it into energy. Animals eat the plants, their animals eat those animals. Remove the sun, and the chain collapses. Life ends. That was the rule. Hydrothermal vents broke it completely. At the base of the vent ecosystem are microbes, bacteria, and archaea that feed not on sunlight, but on hydrogen sulfide, the toxic gas pouring out of the vents. Through a process called chemosynthesis, they convert that chemical energy directly into organic matter. If that changed the way you think about the ocean, or about life itself, hit like. It genuinely helps this channel reach people who would never otherwise hear about any of this.